Hi, Bobby.
Hello, my name is Bobby Ilg. I'm an architect in Ottawa and a part-time professor at Algonquin College in Ottawa. We have recently built our own personal home based on EcoNest strategies for a clay straw timber frame home. This is the home that you see right here. I stumbled upon building biology in Paula Baker report approximately 4 or 5 years ago, and since then I've really engaged the studies of building biology and natural and healthy building principles. And where that kind of led was into a lot of workshops at EcoNest. Paula and her husband, Robert Laporte, their company tends to host. And from there, I saw a lot of values of building with clay, in particular clay and straw. And we decided to create a wall system that could be used in a more urban context. So we prefabricated wall panels using clay straw and moved them into place. So we built them off-site and decided to erect the building as a prefab structure.
Describe the panels, please.
Yes, so the panels themselves are a double 2x4 wall system that are filled with a clay straw, what I like to now refer to it as a living insulation. So the clay itself acts as a binder of the straw fiber, which acts as the insulation. So the clay it has a dual purpose. It is a thermal mass, because it has a lot of mass to it, but it also acts as a protector to the straw. So when clay and water are mixed with straw or wood or any kind of cellulose fiber, it tends to coat itself. And if left long enough, there's a chemical reaction that happens and takes place. And you can see a fermenting process. So it's a biological and chemical process that happens as the clay tends to bind itself to all the particles of the straw and wood fibers. And so when you make a wall of this system, because the clay has attached itself, all the molecules of the straw, when water comes into a wall system, the clay soaks it up and then releases it again. And
so it prevents mold, condensation?
Yeah, so any kind of issues with moisture, condensation, or even exterior, because there's just a lime plaster going on the outside of our walls. We have clay plaster on the inside, which is our primary air barrier. And when moisture goes into this wall, the clay soaks it up and keeps all the cellulose dry. Substances like mold or fungi or whatever bacteria you have need some sort of food to grow. And in a lot of cases, cellulose tends to be the food that it grows on in a lot of our wall cavities. But because the moisture or the clay knows how to naturally deal with moisture, it allows the straw and the wood to remain dry at all times. And as long as that clay is able to dry itself out again, it will naturally dry itself out. So one of the keys to our wall system is not using a vapor barrier. And so that was one of the items that I had to prove to the city of Ottawa, that our wall system didn't require a vapor barrier. And in contrary, a vapor barrier was going to ruin the wall system that we were creating. So as soon as I was able to justify why we should not use a vapor barrier, the city were very open to us using this wall system.
Because you had no studies to prove it? It was just experience?
Lots of studies, a lot of papers. This wall system is, within a lot of American codes. It's also in the International Residential Code, and it also has some Canadian CMHC studies that were done in regards to how moisture deals with it. We also did an engineered report which showed Ottawa's climate and how moisture will travel through this type of wall system. So with that collection as part of our substance for proving, I guess, that our wall system didn't require a vapor barrier, yeah, we were able to get an alternative solution to the building code and build this house here.
It's really original because it's not straw bale per se, it's really chopped straw.
Yeah.
And
Yeah.
what are the recipes of what you call the slip? The
The
mixture?
slip is really clay and water. That's all it is.
50-50?
But it's, well, no, it's about 2 parts water to 1 part clay, approximately.
And how
It's a
many
little
parts of
different.
straw after that?
Oh, you would, gosh, probably 2 bales will do that. Or what is it? No, 2 bags of clay, 4 equivalent parts of water make up approximately 1 bale of straw, a good bale of straw. So that's the approximate.
How many gallons or liters of water and clay for two?
For a 50-pound bag of clay, it is approximately, gosh, 10 gallons of water, approximately. I mean, I'm just throwing out numbers at this point. I would have to go back. It's like 10 to 15 liters of water.
So for 2 bales of straw, you've got a
At
bag?
least 15 liters of water in that. Well, I'd say 30 liters of water, or 30 gallons of water inside that wall. So it does take some time. For
Not
the
in 2
clay
bales.
straw. For 2 bales,
That's a lot of water.
yeah.
How long did it take to dry?
Because we're building 3.5-inch wall systems, they tend to take about 3 to 4 weeks to dry. If we built a 12-inch wall like this, it would take minimum, I think, 4 or 5 months to dry. So it's
Like hemp walls.
It takes an extremely long time.
Hemp concrete takes
Yeah.
a long, long time.
Yeah.
So,
So
you,
part of the process is we try to, really emphasize the importance of mass on the interior, but I've also read some European reports where it really showcases the importance of a little bit of mass on the outside as well. And we've sandwiched our 2 panels with an eco fiber board, which is Sonoclimate Eco 4 board, and it's
in between.
in between our panels. So we infill that as almost like a little blanket that exists in the middle of our wall system that allows some thermal mass and insulation, living insulation on the inside and on the outside to help protect what I would consider the weakest point in that wall system, which would be the fiber insulation. But it is that blanket that I think really allows these walls to work in a slightly more modern way in our climate. So they will retain the heat that we use from radiant sources like our radiant floors or the radiant use of our fireplace behind me. And they will store a lot of that heat. They will store the passive energy that we get from the sun as they shine on these walls. And it will help heat and also cool the building in the summer months.
How thick will the interior plaster be?
The interior plaster is about 3/4 of an inch at this
Okay,
point. On
it's a good
average.
thermal mass.
Yeah. Well, and then we have 3.5 inches of clay straw,
Yeah.
which has a ridiculous amount of weight. I have a sample to show you.
Oh yeah,
So come with me, Andre.
yes. Tell me about the R value of the walls.
Okay, the R value that we have for the insulated central core, the fiber board, has about a continuous R12. The clay straw itself, both interior and exterior, have approximately another R12. So we're at about an R24, but an R12 of that is continuous insulation. The key to this is
R12 is the Eco 4?
yeah, the Eco 4.
You've got how many layers? Because it's R4?
It's approximately 4 to 4.5 inch. I guess 4.5 inches inside the middle of our wall.
Okay.
So I mean, it's not a heavy, reliant wall system on insulation. I'm a strong believer that thermal mass have qualities and health qualities that unfortunately insulation cannot provide us. So I'm a little bit moving, I don't know, energy efficiency is important, but it's one part of the equation. We're currently working on a project, a living building challenge project in just south of Ottawa, and energy efficiency is only considered one of 7 main components that they work with. And they put, and which I love about it, they put as much emphasis on water as they do on energy.
Savings
and the need to have a positive water outcome for the entire site, including the management of water that comes onto this site through drainage and other means. And most of the world understands the real importance of conserving and dealing naturally with water. For whatever reason, in North America, and especially Canada, we have just not even thought about it. So there's some really exciting septic systems that we're exploring there, where we're trying to bring in septic waste into or out of the building, treat it with a natural garden, and extract the clean water from that to reuse back into the building. So all of our waste goes back into reuse in the building.
That's been approved by the city? Where is that?
That will be, yeah. It's being used in a lot of northern US states.
With reeds or?
I don't know the whole logistics. We had brought in a landscape architect out of Michigan to come in and help out with this process. And we're in the early stages of that, but I don't know. It has so much validity on even a small scale to really show people, and even from a small home point of view, another alternative to a septic system that we're quite used to, and one that I think has a lot more long-term benefits.
So tell me about the property here, the history of it, and the layout of the house.
Yeah, so the house itself is, we live in a little community in Ottawa that has a lot of lots that are about 50 feet by 100 feet. So we didn't have a lot of space inside the yard to be able to build with this type of construction. So we developed a prefab construction technique that allowed us to bring in panels and build on a very constrained site.
You had a house here that you demolished?
Yes, we did. We removed the existing home. It was a 1940s wartime home. We tried to salvage as much as we could. We lived in that home for 5 years, and unfortunately there was a lot of repair and upgrades that were required. So we had to make a decision as to, put a lot of money into that house, or to consider building something that we felt could be a prototype for future homes. What you see here is the library and dining space. This has it's a construction site still, but this is going to be a 2-story space that allows for a real look on all the trusses and timbers that exist inside the space. So you can see we have a plastered ceiling, which is American clay, and all our exterior walls are plastered as well.
And this is typical EcoNest timber framing?
Very, very EcoNest. This is actually a Japanese truss that you're looking at. A lot of Japanese traditional joinery that's put into this side of the building. Our other half of the building is more European in the nature of the timber frame.
And this was designed and assembled by Robert Laporte?
This portion is, yes.
Yeah.
The other portion was completed, in line with Robert's plans, but also with a company called Dwellings out of Perth, who helped with all the timber framing of it, and cutting the timbers, ordering the timbers, sourcing the timbers. They're all white pine that come from the Perth area, so it's nice to use local materials for sure.
Okay.
So I wanted to show over here, this is going to be eventually our kitchen space. The kitchen space will have and consist of one island and one back counter. And here we have a sliding glass wall that opens up into what we consider a courtyard space. We've designed our entire house as a U. One for cross ventilation, because I'm a pretty strong believer that our energy crisis isn't in the winter, but actually in the summer, with the use of air conditioners. From an ecological point of view, I can't think of anything worse than an air conditioner. So natural ventilation and a lot of operable windows became a big part of my design scheme of this project.
Tell me the problems with air conditioning.
Well, outside of pumping cold air into an interior and pumping more hot air on the most extremely hot days of the year outside, it has a lot of other environmental issues, from depleting the ozone to whatever gases that go into that. Not to mention, it is a huge resource on our electrical systems and resources. But the fact, on our hottest days, we pump more hot air into the atmosphere just does not make sense to me. Not from an ecological point of view, anyway. So cross ventilation and using the stack effect, we have some skylights up above that we can open to allow the movement of air through multiple stories, and we don't have an air conditioner and don't plan to have one. With the thermal mass, the earthen floors, the amount of cooling that will happen in this building, there will be days where it's not it's not 20 degrees or whatever everyone likes to live in, but it will be extremely comfortable, and I think that's very important from an ecological point of view. And I'm not a big fan of the feel air conditioning brings in most interior environments.
And building biology is all about getting close to nature.
And fresh air. Fresh air brings in certain ions. They're called negative ions, so electrical charges that replenish our body and make us need to be closer to fresh air and the exterior, right, outside areas. And by using air conditioners and really airtight buildings, this house is very airtight too, but it's done in such a way that we can open still our windows and manage.
In winter also?
Yeah.
No air exchanger?
We do have an HRV.
Okay.
I'm curious how much we'll use it, because I do plan to open the windows in the middle of winter. We won't have an issue because of the mass we have in this house. There's a lot of it. And
so all the floors are heated here? How about upstairs?
Paula tells me, and she's lived in a lot of northern climates as well in the U.S. They live currently in Oregon, where it gets quite cold too. They haven't used their radiant floor ever. And they've lived there for 8 years. They use their masonry heater, and that's it.
Yeah.
So the walls themselves, once you get them warm, they stay warm a very long time.
What have you planned for heating upstairs?
This heater will do most of that too.
Yeah, even if it's over here?
Yeah, it'll do most of it. Eventually we have the radiant floors, so we will probably use it on really cold days, but I'm curious as to how much. I'm actually planning on also running the radiant tubes into our rain harvesting cistern. We have a 10,000 liter rain harvesting cistern that we're going to be using in this house. Again, water is, I think, the one jewel we have that we don't really appreciate in Canada enough. So in our cistern, we'll be collecting and storing all our rainwater, which we'll be using for everything from toilet use to laundry use to to all our hose bibs, all our unpotable water, if you will. I think it's only a matter of time before we'll be able to use that for showers and for majority of our lived-in water here. But unfortunately, the codes don't allow for it today, so we're going to leave a little bit of the plumbing somewhat available to be altered in the future when that is available.
And you say you're going to heat it?
Well, no, we're not going to heat the water will be heated with indirect or I guess some water heaters for sure, the rainwater, because we are using it for laundry.
You mentioned the floor heating?
But the floors, we are going to heat it with a boiler system, but we're also looking at actually running our floor cooling system as well. So running our tubes into that cistern and allowing the rainwater and the earth to keep it fairly cool in the summer and then pumping it through our floors. I think cooling systems can work extremely well. I've seen a lot of examples of it, but I think the key is that you shouldn't cool the water in an unnatural way. So using, electricity and making it too cold. I think you can run into issues in a mass floor.
Condensation.
But if you use, exactly, condensation and other items. But if you just bring it down, even to 15 degrees, that water, it will damper and cool this floor significantly, so that it's much more achievable for summer months.
And are you using a gas or oil or an electric boiler?
We're using an electric boiler, which will probably be run on solar PV. Unfortunately, I need to see how long we use this. If we use the radiant floors a lot, I would consider a geothermal system. However, I have a feeling we won't be using it as much as one might if they didn't have as much mass in our
Or you
house.
could use a pool heat pump.
Yeah. So we could look at some other options.
Yeah.
I mean, the dual electric boiler, though, it does all our domestic hot water, which is showers, all your, washing dishes, etc. But it also does the radiant floors if we need be.
So
it's a
there's no
dual
tank,
purpose.
no hot water tank?
No, this replaces that.
Dual? Two
Yeah,
burners?
it's a dual system.
Okay.
It's very, very nice. I mean, Quebec understand electric boilers much better than Ontario because, again, electricity isn't quite as expensive as it is in Ontario. We've relied largely on natural gas, which, of course, in a few months from now, we will have eliminated all natural gas, oil, and propane from our life. So it's a step I needed to do, and I think a step that's very achievable for many. And how you deal with your electricity can be done in a lot of wonderful ways too.
Is natural gas more harmful to the environment than air conditioning?
I don't know. It depends who you talk to. I think the pure extraction of natural gas can defeat the entire purpose of insulating or highly insulating a passive house building. So your heat source, I think, is from a carbon extraction point of view. The only purpose we have of adding insulation to our walls is to reduce our carbon footprint. And if you use something like natural gas to heat and cool, essentially you've just obliterated your carbon footprint just through this pure extraction of that natural gas.
It can also make people sick in homes if there's a leak.
Or
Slow
homes
leaks.
blow up.
Many of them many of
fires.
them have very, very, very slow leaks where chemically sensitive people cannot enter the house.
Yeah. So from a chemical sensitivity, we've eliminated formaldehyde. All our millwork will be made with non-formaldehyde products.
What are you using for cabinets?
All our cabinets will be made with Pure Bond. It's a soy-based adhesive that they use in their system. Wonderful, wonderful product.
So they're plywood?
Yeah,
cabinets?
it's a hardwood covered veneer plywood that does not have any formaldehydes in it. And it's almost the same price, but unfortunately our cabinetry industry just haven't recognized the importance of it.